In today's lesson, now that we've looked at how to use trigonometry to solve for missing sides, well, how can we use it to solve for missing angles? So the first example problem that we're going to look at, you'll notice I have two missing angles. I have an x and I have a y. And for both of these, I can set up a separate equation depending on what my perspective is on each problem. So let's just jump right in and then see as we're going how we're going to use the calculator to solve these out. So if I approach these the same way I did with our last lesson, I'm going to identify my angle, write my ratio, and then solve out what I have. So let's start out with x. So in our triangle, again, I always like to, just to visually help myself out, circle the angle that I'm using, and then determine the sides that we have. So x is directly opposite from the 3, and the 4 is going to be the hypotenuse no matter what. He's straight across from that right angle. So which one of our rules uses opposite and a hypotenuse again? And again, if you need to, as you're working through these problems, write that whole SOHCAHTOA mnemonic. I like to write it down the column of my paper while I'm working because, again, it gives me the exact order of the fractions I need to use. And the one that uses opposite and hypotenuse, well, that's going to be our sine ratio equation. So let's write it out. So we have sine of our angle x equals our opposite over hypotenuse. And in this case, that's 3/4. Now, with all the problems that we did before, our x was actually part of the fraction, whether it was in the numerator or denominator. And all we had to do was isolate that x, get it by itself, and plug straight into the calculator. These problems are a little different. We've got one extra step, actually two extra steps that we need to do, but they're very quick, and it's really just about making sure we have the right perspective of what we're solving for. And we're trying to solve for that angle. We need to know, well, what angle would we have had to plug into this equation to yield that answer of 3/4? So I want to think backwards. And so the way we can write out that we're kind of thinking backwards on this is by writing something called the sine inverse. So the way I write this is sine with a -1, or sine inverse, and I flip-flop where my fraction and my angle are. Now, the only time that I can flip that around is when I'm using that -1 as part of my kind of sine function, the thing that I'm plugging my stuff into. And this signifies, again, that we're kind of thinking about the problem backwards. We're trying to eventually make the calculator say, hey, you would have had to use this angle to make this equation work. So let's pop over to our calculators and see how to type this in. So again, you can use this on a TI calculator. If you are using one of those on your practice and your assessments, again, have me pop into your breakout room during your work time so we can talk about how to approach that. But I'm going to focus on using the Desmos calculator and the Schoology scientific calculator, since that's what you're going to be using most often. So let me pop over to that screen. And again, this screen, these calculators are available if you go back to the main folder in our Schoology Unit 7 folder. This is the very first link that's in there, the scientific calculators assessment. And again, you do not have to submit this. This is just so you have access to this in the same format that you would see in any assessment. Okay, so before, when we were doing problems, for the Desmos calculator, you could just type things in with your keyboard. So if you wanted to use like sine of 32, you could just open up your keyboard and just type in sine 32, and it would spit out your answer. But we can't do this just with a plain old keyboard on your computer. So for this, we'd actually need to use the keyboard in Desmos. So if you hit this little keyboard button, and you can do this if you're on a touchscreen computer, if you're on a tablet as well, you need to go into the functions section. So that big button on the right, functions, and the very first one on there is trig. So if you need to, you can actually type in your sine, cosine, tangent functions right from here. But notice that second column has sine to the -1, cosine to the -1, tangent to the -1. Anytime you're solving for an angle, this is what you want to use. So the way we wrote our equation was sine inverse, so sine -1. And then we typed in our fraction, 3 divided by 4. And nice thing about Desmos is it automatically puts that in as a fraction for us, so it looks just like our equation does. And notice it's now spitting out that expression 48.590377, etc. So if that's the correct way to do this, then we should be able to check this on our calculator on Schoology as well. So clicking on the Schoology calculator icon, again, notice I'm in radian mode. I need to change it over to degree mode. And the kicker with this one is you want to hit the second button. As soon as you hit that button, notice your options change. So now we have sine inverse, cosine inverse, tangent inverse. Do not use that bottom row with the H's. That means something different that you might approach in pre-calculus or calculus. So same sort of thing, I'm going to type in sine -1. It types in as a sine. Before we had graphing calculators to do this, we typically called this something called arc sine. So when I was in class, when I was in high school, that's what we called it. It does the same function. And we're going to do the same thing, 3 divided by 4. And this calculator just puts in the division sign, which is fine. And then when you hit equals, it spits out exactly the same angle. So it does not matter which one of these tools that you use. Okay, let's pop back over to our examples. So again, sine inverse of 3/4, when we plug that in to get our answer for x, we got out approximately 48.590. I'm rounding up because my next digit is a 7. But this is an angle, so I'm going to put the degree mark so I have my correct units. There we go. And so wait a second. Well, now we know we have a 90-degree angle. We know we have x, so we should be able to just subtract from 180 to find our solution. But I'm going to use trig just to double check to make sure that these answers are going to work out properly. So let's change our perspective. Now we're going to look at the y. So according or from the perspective of the y angle, well, now the 3 is actually an adjacent side. 4 is still a hypotenuse. What uses adjacent and hypotenuse? Well, that's cosine. So my equation to start out with will be cosine of my angle y equals 3/4. But again, I can't just plug that into the calculator. Cosine is kind of super glued with that y. We can't separate those out. Our numbers aren't going to make sense if we try to do that. So we need to do that cos inverse to let us flip-flop our angle and our fraction. And then same thing, if we go to type that in the calculator, that is going to give us approximately 41.4096 degrees. And again, not a bad idea. Feel free to pause the video, pop over to that page on Schoology and test out to see if you get the same answer. Okay, so at this point too, now I would suggest go ahead and pause the video, and I just want you to check, hey, what values am I getting out for these? So the problems that I want you to just straight plug in the calculator, no setup necessary, is your A, B, C, and D. So find the values of each one of the inverse trig functions. In other words, your sine inverse of 0.7543, etc. Okay, so hopefully you popped back out to see what you got on your problems. Okay, let's plug these in to see if we agreed. So sine inverse of 0.7543, I'm getting out approximately, it's actually, let me change my color because I know green is not the easiest to see. So this comes out as approximately 48.9642 degrees. If I do that with cosine and 0.5, I get a very nice number. That one comes out as exactly 60 degrees. And I do that with cosine inverse of 3.5, then wait a second. You're getting some form of error message. That's on purpose. We'll see why in a sec. Tangent inverse of 2.5. Well, if I plug that in, that one comes out as a value. That comes out as approximately 68.1986. I have to round up because the next number is a 9. So why didn't C work, but D did? So every single time we look at these problems, your sine, your cosine, every time we look at them, sine, of whatever angle is going to equal our opposite over hypotenuse. Our cosine of whatever angle is adjacent over hypotenuse. Both of these have hypotenuse in the denominator, and the hypotenuse is the biggest side of your triangle, of any right triangle, no matter what. But if you're looking at your tangent ratio, so tangent of an angle is opposite over adjacent. You could have any combination. Sometimes the opposite side might be bigger, sometimes the adjacent side might be bigger. And so when you plug in a tangent value that's bigger than 1, you have no problems. But if you plug in a value that's bigger than 1 for sine inverse or cosine inverse, you're going to get an error message because that's just not making a possible right triangle. So sine inverse and cosine inverse have to be less than 1. Actually, technically, less than or equal to 1 every single time, or you will get an error message. So let's do some practice problems to make sure that we've got the process down. Okay, here we go. So example 3 and example 4. So again, just like you were solving out before, identify your angle, identify your sides. So 4 is our opposite side, 1 is our adjacent side. Which ratio uses that? Well, that's our tangent. So tan of our angle x equals 4 over 1. So again, to solve the x to get the x by itself, I have to do that flip-flop with tan inverse. Lets me flip my fraction with my x. Now notice I'm writing it as 4 over 1 because I don't want to lose track of what step I used, but what's 4 over 1 actually equal to? Yeah, just 4. So if I type in tan inverse of 4, again, plug that in a calculator, see what spits out. I'm getting approximately 75.9638 degrees. Alrighty, number 4, you can identify your angle, identify your sides. 12 is our opposite, 16 is our hypotenuse. What uses opposite in the hypotenuse? That's sine. So sine of our angle x equals our opposite over hypotenuse. Again, I've got to play switcheroo. Only way to do that is sine inverse 12 over 16 equals x. And then I can plug that straight in my calculator. I do not need to worry about reducing the fraction before I type this in. The calculator will take care of that for you and still give you your approximation for your angle of x. So x is approximately equal to 48.5904, rounding up because that next digit is a 7. Wait a second, that seems familiar, doesn't it? Let me scroll back up real quick. 48.59. Hey, wait a second, we had that in our very first example. So in our triangle, we only had 3 over 4. Let's go back down to the example we just did. 12 over 16, what does that reduce down to? And that reduces down to 3 over 4. That's why we got the same answer out for that. Even though technically we had different values, we had a similar triangle, but it still had the same relationship between the sides versus the angles. Alrighty. So let's do an example that actually pulls both things together, solving for sides and solving for angles. So both this lesson and the last lesson. So x, y, and z. So a few different ways to do this. Again, I'm going to use what we just learned to solve out for x. I know that, well, can I do that? I have my opposite side, but I don't have any other sides labeled. So actually in this problem, I can't quite set up my trig ratio yet to solve for x. So let's do something different first. Let's maybe solve for y first. And mathematicians, we do this all the time. We say, okay, well, let's try solving for this. We don't have enough information yet. So let's look for another set of info that we could potentially use. So now let's try solving for y. So for y, let's see here. My only other angle right now is 58. Okay. So I can also solve for using the 18. So let's see here, compared to my 58 degrees, my y is my opposite side, my 18 is my adjacent side. What ratio would use that? That's going to be our tangent. So tan of 58 degrees equals y over 18. So just like we did last class, I'm going to go ahead and multiply both sides by 18 to clear my fraction. So 18 tan 58 degrees equals y. And I'm ready to plug in my calculator. Y is by itself. So 18 times tan 58 gives me that y is approximately equal to 28.8060. So you round to the nearest 10,000th. Yep, I want my 4 places. Alrighty, so that's our answer for y. So do we absolutely need to use trig to solve for the x and for the z now? I could absolutely do that. So now I have a second side. I could solve out for x using trig. And so actually, let's do that and then compare it to another method. Did anybody see another way we could solve out for x? And don't forget, all of the angles in a triangle are always adding up to 180. So you could absolutely find your answer with that. But let's see if we have comparable answers when we try this out. So 2 methods for x. So first off, if I do 180, take away 58, take away a 90, I end up with minus 58 minus 90, 32 degrees. And so we should get that x equals 32 degrees. Let's see if the trig proves that as well. So now that I have my y, let me go ahead and do some relabeling. So we now know that y is 28.8060 compared to our angle x. I have my opposite and my adjacent, which means I can use the tangent ratio. So tangent of x equals 18 over 28.8060. And so do your flip-flop. So tan inverse of 18 divided by 28.8060. This is why we want to use things with as many decimal places as possible, because now I will have a much more exact answer if I use that entire decimal. If I just used 28.8, I wouldn't be as accurate. And the calculator can interpret. So usually you don't want to put decimals inside a fraction, but your calculator can handle it. And I'm getting out that x is approximately equal to 32.0000. We got out the same answer. Does not matter which method we use. I'm going to stick with that exact version though, because again, the more exact we can get, the more exact our final answer will be. And so then again, 2 methods that we could use. We could use Pythagorean Theorem on this one if we wanted to. So let's go ahead and do that. So we know that our 2 sides, our 18 squared plus our y squared, should equal our z squared. And so now we just have to plug in the numbers that we know. So 18 was already there. Our y, we came out with 28.8060 squared equals z squared. And so simplify that out, 18 squared, well, that's 324. 28.8060 squared is approximately 829.7856. Put those together, we get 1,153.7856. And then taking the square root of both sides, we get that z is approximately equal to 33.9674. And again, if you wanted to, you could verify this using trigonometry, and you could use any version that you want, as long as you're careful of identifying which angle you pick and which values, how many decimal points you're using in those values. Alrighty, I'm going to go ahead and stop the video, and I want you to try out number 6, 7, and 8. I'm going to have the fully completed version in the completed organizer, but if you need me to talk you through them, definitely pop back in to, you're already going to be in your breakout room. But what I may do is send out a message. If I have a lot of people that are asking for that question, I'll pull people back into the main room. Anyone that wants me to go through them, we can. Talk to you later.